Hello friends, now in this session we will take a chapter called Time and Work. This is an important chapter for almost all the exams. It's an easy chapter and it's a small chapter. So let's take all the concepts one by one. First, to understand the concepts, let's take a simple situation. Suppose there is a tank and the capacity of this tank is 500 liters. So this is the total capacity of tank. Suppose we have a tap working in this tank. Suppose this name of the tap is tap A. It can fill 30 liters water per minute. Now let's look at this one by one. The capacity of the tank, which is 500 liters, we have to fill this. So this is the total work to be done. Right? Then this 30 liter water per minute, that is tap A, that can fill, that will be the rate of filling by A. It can also be said it is speed of A. Right? And they are equal to 30 liters per minute. So in every 1 minute, the tap A can fill 30 liters water. So now if I ask, in how much time this tap A can fill this tank, how will you do that? Right? So look at the question very carefully. It says in how much time this tap A can fill this tank. So the tap A can fill 30 liters in every 1 minute. That means to fill 500 liters, I hope you can understand that the time required by A to fill the tank will be total capacity divided by the rate of filling or the speed of the tap A. Okay, so the total capacity is 500 liters divided by 30 liters per minute. So this will be the time taken to fill the tank. Liter and liter will get cancelled and we'll get minutes, and this will be 500 by 30 minutes, whatever answer you get. Let's say it is 50 by 3, that is 16, 2 by 3 minutes. Hence the answer is, you can convert this 2 by 3 minutes into seconds, you will get 16 minutes, and we know that 1 minute is 60 seconds, so 2 by 3 minutes multiplied by 60, 20 times 60, 22 is 40, so it is 40 seconds. So the important thing is to understand that the time taken to complete the work is total work. This total capacity is the total work divided by the speed of the worker, speed of the filler. Alright, let's take another situation. Suppose we have the same tank which is 500 liter capacity and there are two taps working in it. Suppose this is tap A. It fills 30 liter water per minute. Alright, and there is another tap which is, let's say, smaller one. Let's call it let's say tap B. It takes 20 or it fills 20 liters water per minute. So tap A fills 30 liters per minute, tap B fills 20 liters per minute. Suppose the question is, in how much time tap A and B together can fill this tank. Right? Now how do we do this? I hope you can see that the total work is the tank. So the total work is still equal to the capacity of tank, which is equal to 500 liters. But now there are two taps working. Right? So one tap is filling 30 liters in every minute. The other tank is filling 20 liters per minute. So now the next speed at which the tank is filled, you see, one tap is giving 30 liters water per minute, the other one is giving 20 liters per minute. That means the total water accumulated or collected in the tank in 1 minute will be 30 plus 20, and that will be called net speed. Net speed will be the speed of A plus speed of B, which is 30 liters per minute plus 20 liters per minute. which is equal to 50 liters per minute. So the time taken to fill the tank by A and B together, please understand A and B together, this will be equal to, always remember it is total work to be done divided by net speed. This is what we have to be careful. So if there are two people working, their speeds will add, right? So this is equal to 500 liters divided by 50 liters per minute. Now 500 by 50 is 10, so the answer is 10 minutes. So you can see that alone tap A was filling in 16 minutes 40 seconds, whereas together A and B can fill it in 10 minutes only. Suppose it was asked what is the time taken by B alone to fill the tank. So that would be, it is 500 liters divided by, the speed of B is 20 liters per minute. So 500 by 20, that is 25 minutes. So B alone could have filled in 25 minutes. A alone could have filled in 16 minutes 40 seconds. Whereas A and B together, they take 10 minutes, which is obvious. Suppose one person alone can do it in 16 minutes 40 seconds, one person can do it alone in 25 minutes, then obviously together they'll fill it in less time. The whole idea is to understand, what do we get from here? We get that time taken is equal to total work divided by net speed. So if there are more than one people working, you add the speed of everyone. Alright, so this is the basic concept of this chapter. Now let's take more situations. Now suppose we have a tank and it says there is a tap A which can fill the tank in 30 minutes. We are changing the question now. And suppose there is a tap B which can fill the tank in 20 minutes. So I'll write it. Tap A and B can fill a tank in 30 minutes and 20 minutes alone respectively. So you have to understand that A alone can fill it in 30 minutes, B alone can fill it in 20 minutes. In how much time they can fill the same tank together? How do we do this question? In the earlier situation, the total work quantity was given. Here it is not given. But please understand this time given 30 minutes and 20 minutes are for the same work, that is the capacity of the tank. A in 30 minutes can fill the full tank, can fill this whole tank. B alone in 20 minutes can fill the whole tank. So what we do is, now there are many ways of doing this question. We'll take them one by one. First let me say method 1. Method 1, you have done it in the school, right? It is also called fraction method. Okay, so let's take a look at that first. Here we are saying that tap A in 30 minutes. What does it do in 30 minutes? It fills one tank. So the quantity of work we are taking as 1. Alright. That means tap A in 1 minute. What will it do? To understand this, let me put it this way. In 30 minutes, it fills one tank. So in 60 minutes, what will it do? Time is doubled. So it will be able to fill 2 tanks. In 90 minutes, what will it be able to do? It will be able to fill 3 tanks. In 120 minutes, it will be able to fill 4 tanks. Come back. In 15 minutes, what can it do? So in 30 minutes, it is filling 1 tank. So in 15 minutes, it will be able to fill 1 by 2 or half of the tank. In 10 minutes, so 10 is 1/3 of 30. So the work done will be 1/3 of the tank. How do we get that 1 by 2 or 1 by 3? So when it was 15, it was 15 by 30, that was 1 by 2. When it is 10, it is 10 by 30, that is 1 by 3. When it is 1 minute, it will be able to fill 1 by 30 tank. Right? So in 30 minutes, it fills 1 full tank. So in 1 minute, it will be able to fill 1 by 30 tank. So the work done by A is, or you can say the speed of A is 1 by 30 tank per minute. Similarly, tap B in 20 minutes it fills the entire one tank. That means in 1 minute, it will be able to fill 1 by 20 tank. From here we say that speed of B is 1 by 20 tank per minute. Alright. So we have the speeds of A and B. So what will be the combined speed of these two? So combined speed, which is also we have called it as net speed, combined speed or net speed, it will be the equal to speed of A plus speed of B. Now speed of A plus speed of B will be 1 by 30 plus 1 by 20. Right? Let's take LCM of 30 and 20, it gives us 60. 32s are, so 2 plus 3, this is 5 by 60, which is 1 by 12. So together, combined speed, together they can fill 1 by 12 tank per minute. Alright. So now we have to find in how much time. You can directly find it is 12 minutes from here. So what is the method for that? In how much time they can fill the tank together? So time together to fill the tank will be equal to total work, that is one tank. I'll write it again, total work divided by net speed. It is always total work divided by net speed. Now total work is one tank, net speed is 1 by 12 tank per minute. Right? So what will happen? 1 by 12. 12 goes in the numerator, so it becomes 12 minutes. That means the time together is equal to 12 minutes. Alright, so this was the fraction method. Now, let's reduce the length of this process. This is always going to take a longer time. It will take a lot of space and time also. So we'll reduce the whole process. Okay, and we'll create a formula. Alright, so I will call it method 2 now. Okay, and we create a formula for that. Let's see. Now we'll take up method 2. It is actually the extension of fraction method, but we'll create a formula from here. How? Let's see. If I call the time taken by A as T1 and time taken by B as T2. So now tab A in T1 minutes can fill one full tank. That means in 1 minute it will be able to fill 1 by T1 tank, which is speed of A. Right? So speed of A is equal to 1 by T1 tank per minute, or 1 by T1 work per minute. Similarly, tab B in T2 minutes, it can fill one tank. That means in 1 minute, what will be able to do? It will be able to do 1 by T2 works, that is 1 by T2 tank, which is the speed of B. So we can say the speed of B is 1 by T2 tank per minute. So the net speed will be equal to speed of A plus speed of B, which is 1 by T1 plus 1 by T2 tank per minute. Alright? Now, the time taken by both of them together will be equal to total work divided by net speed. Now total work is one tank divided by net speed is 1 by T1 plus 1 by T2, and the answer will be in minutes. Look at this very, very carefully. Now if you simplify, when we don't know the numbers, we can take LCM as T1 into T2, and in numerator we will have T2 plus T1 minute. Now this T1, T2 will come in numerator, so it will become T1 into T2 divided by T2 plus T1. This is the time together. So if we know the individual times taken by some people, taken by two people to do a work, we can directly say the time together will be T1 into T2 upon T1 plus T2 or T2 plus T1. Here it is plus, so whether you say T2 plus T1 or T1 plus T2 doesn't matter. So in this question it will be T1 is given as 30, T2 is 20, divided by 20 plus 30. So we have 600 divided by 50, that is 12 minutes. So this is one very beautiful method of doing this question. How? We can directly create a formula. This is the formula that we can directly apply. So in future, whenever you get a situation wherein two people are working their individual times to do the complete work is given, you can directly find the time together would be T1 into T2 upon T2 plus T1 or T1 plus T2. Alright, so I'll write the summary of this. So in future, you do not need to do all this. You can directly apply, straight away you can start from here. Like in this case, we do not need to know this, or we do not need to write all these things. We can simply say that time together for two people, remember it is only for two people, so this is a condition, is equal to T1 into T2 divided by T1 plus T2. This is only for two people, and there is a condition. The condition is that, this is a very important condition. Condition is that both workers, both people or worker or taps, it doesn't matter, both workers should have worked from start to finish at constant speed without any break. So that means if there is any break in between, this method will not be applicable, right? So please understand this method is applicable only if both workers should work from start to finish at constant speed without any break. Now, how do we know whether the speed is constant or not? If speed is different, it will be mentioned in the question, so nothing to worry at all, right? Here it is not mentioned, so we'll assume that they work at constant speeds. Again, how do we know whether there is a break or not? If there is any break, it will be definitely mentioned in the question. Here not mentioned, so we'll assume that there is no break. So we can directly apply this formula in this question. So that means this becomes a very simple question. You just read the question, just take the formula 30 into 20 divided by 30 plus 20, which is 600 upon 50, that is 12 minutes. Even if you change the context of the situation, the formula will not change. For example, if I take a simple question, Ram can do a work in 30 days and Shyam can do the same work in 20 days. In how much time, in how many days they can do it together? Still in this question, it will still apply the same formula. It will straight away say 30 into 20, the time together is equal to 30 into 20 divided by 30 plus 20, which is 600 divided by 50, and that is 12. The only thing is here unit will change because the units are in days, so it is 12 days. So it is always beneficial that we apply this formula in this situation. Alright, so this is one very good method of this question. Now let's take method 3. The third method is very, very important because in all other cases, in fact, in most of the cases, this method is going to be really, really useful, right? It is called LCM method. Remember the conditions in the previous case? It's called LCM method, right? It is also called work speed method. All right, let's take it. How does it happen? Remember, in the previous case, when we used the formula, there was a condition that two people should have started and finished together, right? There should be no break in between. What if there is a break? For those situations, we need to know this method. So first we'll apply this method in this question because we have already done this question. It's an easy question. And then we'll see more difficult situations. In method 3, what we do is we assume the total work to be equal to LCM of individual times to complete the work. Individual times to complete work. Right? So in this case, what will be the total work? Here the total work will be, the times given are 30 minutes and 20 minutes. So we'll take 20 and 30 or LCM of 30 and 20, which will be equal to 60. Let's say the total work is 60 and this is a case of tank, so we'll take it as 60 liters. So total work we have got from here. See, in the first method we have used total work as 1 unit. Here we are saying total work is 60 unit. Unit in this case we can take it is a tank, so we can take it as liter. So always assume the total work to be LCM of individual times. So here the total work is 60 liters. Now what does A do? A takes 30 minutes to do what? To fill the tank. Now here the tank capacity is 60 liters. So A takes 30 minutes to fill 60 liters. That means speed of A will be equal to 60. S stands for speed. Speed of A will be 60 by 30. 60 liter by 30 minutes, which is 2 liters per minute. Similarly, B takes 20 minutes to fill the tank. That is to fill 60 liters. That means speed of B will be 60 liters divided by 20 minutes. So this is 3 liters per minute. That means the net speed or the combined speed will be equal to 2 liters per minute plus 3 liters per minute, because both are filling. So it is 5 liters per minute. So the time together, which we know it has to be, there is only one way to calculate time together, and that is total work, which is 60 liter, divided by net speed, which is 5 liters per minute. So if you simplify, it will be 60 by 5, 12 minutes. Alright. So this is one very beautiful method. Here it doesn't make much of a difference because this question was easy. In more complicated situations, if there are more than 2 people, if there are breaks in between, then this method comes out to be really, really well. Okay, let's take more complex situation and then try to understand the method 3 for difficult situations. So let's take some questions for the application of all these methods that we have learned. Alright, let's take up this one. Now let's look at this question. It says Ram can do a work in 40 days. Shyam can do the same work in 60 days. In how many days they can do the work together? Now this is a direct question of the formula method. Right? We have T1 equal to 40 days. T2 is equal to 60 days. So straight away we can calculate, because there is no break in between. Nothing is mentioned, so there is no break. Nothing is mentioned about the speed, so that means we assume that it is constant speed. So time together is straight away equal to T1 into T2 upon T1 plus T2. You don't have to think anything else. So it is 40 into 60 divided by 40 plus 60. So it is 40 into 60 divided by 40 plus 60 is 100. So 0 and 0 are cancelled. 4 into 6 is 24. So that means they can do this work together in 24 days. So this was a very simple situation. So we use formula method. Okay. Now let's look at the second question. It says A can do a work in 30 days. B can do that work in 40 days. C can do that work in 60 days. That means A alone in 30 days, B alone in 40 days, C alone in 60 days. In how many days A, B, C all together can do the same work? Now here we cannot apply the formula because the formula was for only 2 people. That is T1 into T2 upon T1 plus T2. Right? This was only for 2 people. So in this case we cannot apply the formula. So what should we do? We should follow the third method, which is LCM method. Let's assume that the total work is equal to LCM of individual time, that is 30, 40 and 60. Now what is LCM of 30, 40 and 60? Calculate it. So 30, 40 and 60. Let's take 10 common. So we get 3, 4 and 6. Now from 3 and 6 take 3 common. So 1, 4 and 2. From 4 and 2 take 2 common. So 1, 2, 1. So the LCM will be equal to 10 into 3 into 2 into 1 into 2 into 1, which is equal to 120. Let's give some units. So let's use the word units itself. So the total work is 120 units. Now what does it tell us? It gives us the speeds. How? Let's see. I'll put it like this. Time and speeds. A. Time of A to do the whole work is 30 days. Now the whole work is 120 units. That means the speed will be 120 divided by 30. That is 4 units per day. So speed of A is 4 units per day. Similarly B. B does the whole work in 40 days. Whole work is 120 units. So it is 120 by 40. That is 3 units per day. So speed of C. How do we calculate that? C does the whole work in 60 days. In 60 days C can do 120 units. So the speed of C will be 120 divided by 60. That is 2 units per day. Now what is the combined speed of all the 3? So the combined speed of A, B, C together will be equal to simple addition of all these three values. So it is 4 plus 3 plus 2 units per day, which is 9 units per day. So combined speed of ABC is 9 units per day, and we have to find the time taken together to complete the work. So the time taken by ABC together will be equal to the total work 120 units divided by 9 units per day, right? So unit and unit will get cancelled and days will be the answer. So we have 3 cancels 120 40 times and 3 cancels 9 3 times. So it is 40 by 3 days. If you further simplify, 13 1 by 3 days. So this is the answer of the question. Don't worry about the fractions. It is just the value that is important. All right. So this was a very good example of LCM. Let's take some more questions. Now let's take this third question. It says A can do a work in 25 days. B can do the same work in 15 days. They start working together and A leaves after a few days, right? Oh, so they start working together, then A leaves after a few days. Then B completes the remaining work in 7 days. Remember, A has left, so B is alone, completing the remaining work in 7 days. So the work is finished, right? For how many days did they work together? For how many days did A work? Now here we cannot apply the formula because there is a break here. A is leaving in between. Remember, the formula is applicable only when they work from start to finish. So in this case, we cannot apply the formula to find the total time. So what should we do? Same, we follow the LCM method. Let's assume the total work to be LCM of the times, that is 25 and 15, which is 75, and let's put a word units. That means speed of A can be calculated straight away. Now what does A do? A takes 25 days to complete, total work 75 units. So speed of A will be 75 units divided by 25 days, which is 3 units per day. Then speed of B will be 75 units divided by 15 days. So it is 5 units per day. So now we have speed of A and speed of B. SA means speed of A. SB means speed of B. Now, the total work is done in 2 parts. In the first part, A and B are working together. In the second part, only B is working, right? First, let's take the second part. In the second part, B has completed the remaining work in 7 days. So B is working only for 7 days. How much work can B do in 7 days? Now, speed of B is 5 units per day. So in 1 day, he can do 5 units. So in 7 days, work done will be equal to 7 into 5, that is 35 units. That means B has to do 35 units to complete the work. But the total work we have taken as 75. So what happens? Remaining work was already done. So in the first phase, work quantity done would be equal to 75 minus 35, which is 40 units. Now, who does this 40 units? Who is doing this 40 units? This 40 unit work is done by both A and B together. And what is the combined speed of A and B together? So combined speed of A and B together is 3 plus 5, that is 8 units per day. Right? Now, so combined speed of A and B together is 8 units per day and they have done 40 units. So what is the duration in the first phase? What is the time taken in the first phase? It is 40 divided by 8, which is 5 days. That means they have worked together for 5 days. So what is the question asking? For how many days did they work together? The answer is 5 days. For how many days did A work? A worked only in the first phase, the phase in which they were working together. So that answer is also 5 days. But suppose the question asked, what is the total time taken to complete the work? The total time taken to complete the work. So the total time will be first phase 5 days, second phase 7 days. So the final answer will be 12 days. So if the question was, what is the total time taken to complete the work? Then answer is 12 days. For how many days did A work? Answer is 5 days. For how many days did they work together? Answer is 5 days. So this is one very good example for applications of LCM. Alright. Now this question says A and B together can do a work in 24 days. B and C together can do the same work in 30 days. C and A together can do the same work in 40 days. In how many days they can do the work all together? Oh, right. So the time taken by ABC altogether. Then individually alone, that is time taken by A, time taken by B, and time taken by C. So how do we do it? Here, the time is given for two people together. No problem. We can still go ahead and take total work. We can assume the total work to be LCM of the times. The times are 24 days, 30 days, and 40 days. If you calculate the LCM of 24, 30, and 40, 24, 30, and 40, the LCM will be, let's take 2 common. So it is 12, 15, and 20. Then take 3 common from these two. So you'll get 4 and 5. This will remain unaffected. Then take 4 common from 4 and 20. You will get 1, 5, 5. And then finally take 5 common. You will get 1, 1, 1. So the LCM will be 2 into 3 into 4 into 5. Alright. So this is equal to 120 units. So we have got 120 units as the total work. Now look at this very, very carefully. I'll again write the situation here. Let's say A and B together, time given, and we calculate the speeds. Right? Now A and B time together is 24 days. What do they do in 24 days? They complete 120 units. So the speed will be 120 divided by 24. That is 5 units per day. Similarly, B and C. What is the time taken by them? It is 30 days. So their speed will be 120 by 30, which is 4 units per day. Time taken by C and A is 40 days. So speed will be 120 by 40, that is 3 units per day. Now what does it mean? What is the meaning of this 5? This 5 is the combined speed of A and B. That means speed of A plus speed of B. This is equal to 5 units per day. Similarly, B plus C combined speed is 4 units per day. So speed of B plus speed of C is equal to 4 units per day. And from here we get speed of C plus speed of A. That is 3 units per day. So now we have 3 equations and we can solve them to get the individual speeds. Look at this. How? Let's add all of these. If you add all these 3 equations, on the right hand side you will have 5 plus 4, 9 plus 3, that is 12 units per day. What will you have on the left hand side? Look at this very carefully. It is SA plus SA, SB plus SB, SC plus SC. So it is 2 times speed of A plus speed of B plus speed of C. That means combined speed of A, B, C together is equal to 12 by 2, that is 6 units per day. Alright. So the combined speed of A, B, C altogether is 6 units per day. From here you can calculate the individual speeds also. Let's see how. Speed of A, speed of B, and speed of C. Look at this. Combined speed of all the 3 together is 6 units per day. B and C together is 4 units per day. So speed of B plus speed of C is 4 units per day. Put 4 here in place of B and C together. You will get speed of A equal to 6 minus 4, that is 6 minus 4, that is 2 units per day. So we have got the speed of A. Now speed of B. How will you calculate speed of B? Look at this. Here speed of A and B together is 5. Speed of A is 2. So if you put 2 here, you will get speed of B as 5 minus 2, that is 3 units per day. And now very easily you can find the speed of C. Add A and B speed, that is 2 plus 3, 5. Put it here in place of A and B together, 5. You will get speed of C as 6 minus 5, that is 1 unit per day. So now we have combined speed of ABC together. We have speed of A, speed of B, speed of C, and we have to find the time taken by them to complete the work. What will be the time taken by all of them together? The total work divided by net speed. Now total work we have taken as 120 and their combined speed is 6 units per day. Right? So total work is 120 units and combined speed is 6 units per day. So the time taken by all of them together is equal to 120 by 6, that is 20 days. Right? Similarly, what will be the time taken by A alone? The total work is 120 units. Speed of A is 2 units per day. So it will be 60 days. What will be the time taken by B alone? See, 120 units is the total work. Speed of B is 3 units per day. 120 by 3 is 40 days. Similarly, time taken by C will be 120 units divided by speed of C is 1 unit per day, which is equal to 120 days. So this was one very beautiful example of LCM method. Alright. Now let's go to the next question. Now let's take a look at this question. It says A and B together can do a work in 24 days. B and C together can do the same work in 32 days. A works alone for 10 days and leaves. Then B works alone for 14 days and leaves. Then C completes the remaining work in 26 days. In how many days they can do the work all together and individually respectively. Now what should we do here? Let's again, here the time given is only for two combinations, AB and BC. In the previous question it was given for all three combinations. But still, at least 2 times are given. So what we will do is, we will take the total work as still the LCM of these 2 times, that is 24 and 32. You can take LCM of 24 and 32. You can calculate here. If you take 8 common, 8 3s are and 8 4s are. So LCM will be 8 into 3 into 4, which is 96. So total work is equal to 96 units. So if I say A and B together and B and C together, their times are given, that is 24 days and 32 days. Now A and B can do the whole work, which is 96 units, in 24 days. So we can calculate the speeds. Speed will be 96 by 24, which is 4 units per day. What is this 4 unit? It is the combined speed of A and B together. That means it is equal to speed of A plus speed of B. Look at this very carefully. Similarly, this B and C together can do the whole work 96 units in 32 days. That means their speed will be 96 by 32, which is 3 units per day. What is the 3 units per day? This 3 units per day is the combined speed of B and C. That means it is speed of B plus speed of C. Alright. Now, here it says that they are working separately. You know, A has worked for 10 days and then he leaves. Then B works alone for 14 days, then he leaves. And then C completes the remaining work in 26 days. What does it mean? The work is completed. So can I say that the total work done, total work is equal to, A has worked for 10 days. So he must have done some work in 10 days. So we can say the work done by A in 10 days plus B has worked for 14 days. So at least some work he would have done. So B in 14 days plus C works for 26 days. So C in 26 days. Please try and understand this. The total work done has to be equal to the work done by A in 10 days, work done by B in 14 days, and work done by C in 26 days. That should be the total work. Now the total work we've assumed to be 96 units. So 96 units is equal to, now A's speed is SA. We have taken SA as speed of A. Alright, SB means speed of B. And SC means speed of C. Now what is the meaning of speed? Speed means the work done in 1 day. Here we want A work in 10 days. So it can be written as work done by A in 10 days is 10 into speed of A. Remember, speed means work done in 1 day. Similarly, work done by B in 14 days will be 14 into speed of B. Similarly, work done by C in 26 days, it will be 26 into speed of C. So this is the algebraic relation that we have now. Okay, but we do not know the individual speeds. No problem. We at least know that SA plus SB is 4 units per day. Put it here. Let's see what happens. We have 96 equal to, let's do some rearrangements. Here it is 10 times, here it is 14 times. So if I take 10 times speed A plus speed B, what will happen? 10 times speed A is already here. Here it was 14 times speed B. Out of that 10 times speed B is there. So we can take 4 times speed B plus 26 times speed C. Then from here take 4 times speed B plus speed C. So it is 96 equal to 10 times SA plus SB is plus 4 times SB plus SC. So how much will remain? 4 times SB is gone, 26 times SC, out of that 4 times SC is gone. So we have 22 times SC. Right? This is a simple rearrangement that we have done. 10 times SA plus 10 times SB is here. So this is gone. Out of this 10 is gone, so 4 is remaining. So out of this 4 and out of this 4, we combine them together to form 4 times SB plus SC. Why are we doing that? Because we don't have the individual value. We have the combined value of speed of AB. We have the combined value of speed of B and C. We put it here. So 96 is equal to 10 into, what is the combined value of A and B? Combined value of A and B speed is 4. So 10 into 4. plus 4 into, what is the combined value of B and C? It is 3. So it is 4 into 3, right? Plus 22 times speed of C. So I'll write here now, it is 96 equal to 10 into 4 is 40, plus 4 into 3 is 12, plus 22 times SC. Now 40 plus 12 is 52. 96 minus 52. So we have 96 minus 52 equal to 22 times speed of C. Now 96 minus 52 is 44 equal to 22 times SC. So that means speed of C is equal to 44 by 22, that is 2 units per day. Fantastic. So we have speed of C as 2 units per day. Alright. Now see, combined speed of B and C is 3 units per day. If you put speed of C as 2 units per day, you will get speed of B as 1 unit per day. Now, combined speed of A and B together is 4 units per day. If you put speed of B as 1 unit per day, you will get speed of A as 4 minus 1, that is 3 units per day. If you add all the 3, you will get speed of A, B, C combined together, and that will be 2 plus 1 plus 3, 6 units per day. So now we have the speed of every individual person and the combined speed. The question is asking in how many days they can do the work together, right? So time taken by all ABC together will be equal to total work. What was the total work? It was 96 units. Divide by combined speed of ABC. What is the combined speed of ABC? It is 6 units per day. So 16 by 6 is 16 days is the answer. What is the time taken by A alone? So total work is 96 units. Speed of A is 3 units per day. 96 by 3 is 32. So it is 32 days. What is the time taken by B alone? So it is 96 units work. Divided by speed of B is 1 unit per day. So 96 by 1 is 96 days. What is the time taken by C alone? So total work is 96 units. Divided by speed of C is 2 units per day. So it will be 48 days. So we have calculated the time of each and every person. The most tricky part was this whole process where we combined SA and SB for 10 days or 10 times. And for SB and SC we have combined 4 times and we've adjusted. Alright, so this was a very good question. Try to do it again yourself and go through the video again. Alright, now let's go to the next question. Now let's take up a question in which it says that a father is twice as good as his son. Not in looks, in the efficiency of doing work. A father is twice as good as his son. Together, they can complete a work in 24 days. In how many days they can do it alone? They can do it alone individually. Alright. Now, we'll do this question in many ways. Let's say method 1. Method 1 will be the formula method. For that, let's try and understand. Here we are saying a father is twice as good as his son. That means speed of father is equal to 2 times the speed of son. Please try and understand this. When we say father is twice as good, that means the speed is 2 times. That means time taken by father will be half of time taken by son. Right? If the person's speed is higher, the time taken to do the whole work will be lesser. So time taken by father for the whole work will be half of time taken by son. So let's assume that the father takes X days. That means the son would take 2 into X, 2X days. Right? You know, you can directly reach this step. To explain this, I have written all these things. Right? Father is twice as good. So father's speed is high. Father's speed is double, twice. So father time will be half. So if father takes X days, son will take 2X days. So that means time together, we know the formula of T1 into T2 upon T1 plus T2. Here time together is given 24. Time of father is X, time of son is 2X. So X into 2X divided by X plus 2X. So from here we get 24 equal to X into 2X is 2X square plus 2x is 3x. So 1x is cancelled. 2 cancels 24 12 times. So x is equal to 12 into 3, 36. Oh, that means the father can do the work alone in 36 days, and the son can do the work alone in 2 into x, that is 2 into 36, that is 72 days. Right? So this was one very easy question. So this was one method of doing this question. As I said, we'll use multiple methods. Let's take another method. Let's say method 2. Now method 2 is actually the reverse of work speed method. There we assumed work and we calculated speed. Here we will assume speed and calculate work. So speed work method. So it's actually the same. What we do is, what does it say? It says the father is twice as good as his son. Also, there is one important thing that you should remember. Do not mix the methods. This is one different method. Now we are doing an entirely different method. So I'll start from here. Speed of father is 2 times speed of son. So let's assume that speed of son is 1 unit per day. So what will happen? Speed of father will be 2 times speed of son, that is 2 units per day. That means the combined speed of father and son will be equal to 1 plus 2, which is 3 units per day. Now, why are we calculating combined speed? Let's see. They can complete the work in 24 days together. So, total work can be calculated from here is equal to total time is 24 days into the combined speed, that is 3 units per day. See, remember, they are working for 24 days together and the together speed is 3 units per day. So what would be the work for which they would take 24 days? Working 3 units per day. So that will give us 24 into 3, that is 72 units. So the total work in this case is 72 units and together they can finish in 24 days. So what will be the time taken by father alone? Let's see, total work divided by speed of father. Now total work is 72 units. Speed of father is 2 units per day. So 72 by 2, that is 36 days. And the time taken by son will be total work 72 divided by speed of son 1 unit per day, which is 72 days. So this was another method. In this, please understand, we assumed speed and we calculated work. In LCM method, what we do, we assume work and then we calculate the speeds. Right? Now, there is one very small method for this particular situation. So I'll say it is method 3. Look at that very, very carefully. Method 3 is the efficiency comparison method. So here we are also introducing a new term, efficiency. Now, here we are saying that a father, again, the third method is entirely different. Do not mix the methods. A father is twice as good as his son. So can I say, if I say father is F and son is S, then F is equal to 2S. You know, the father is equivalent to 2 times his son, right? That means father plus son will be equivalent to, in place of father we can say it is 2 times son plus son, which is equal to 3 times son. Now father and son together, they take 24 days to complete the work. That means 3 times son will also take 24 days to do a work. Right? So this is a logical method. So together 3 times son. Now understand this. There are 3 people like the son and together they can do the work in 24 days. Now once again, father is equivalent to 2 times the son. This means father alone is equivalent to 2 people who are equivalent to the son. Okay. Now father plus son will become 2s plus s, 2 times son plus 1 times son, that is 3 times son. So like son, if there are 3 people, they can do the work in 24 days. So if there is only son, only one person, how much time will it take to do the work? Now here, this is a point where a lot of people make mistake and they say 8 days. No, it is not unitary method. It is not directly proportional. See, understand. People and time taken to do the work are inversely proportional. When you increase the people, number of days taken will reduce. Right? If you decrease the number of people, number of days will increase. Right? So this is inversely proportional. So here, number of people is becoming from 3 to 1. So number of people is becoming 1/3. Number of people is becoming 1/3. So time taken will be multiplied by 3, that is 72 days. Right? So 3 people like the sun can do the work in 24 days together. So one sun alone will be able to do the work in 24 into 3, that is 72 days. Alright? So the time taken by sun is 72 days. Hence the time taken by father will straight away be equal to half of the time taken by sun, that is 36 days. So these are 3 different ways in which we could have done this question. Alright. Now let's take the concept of negative work. Right? Now what do we mean by this? This is very easily explained by the situation of tank, a filling tap, and a leakage. So let's say it is tap A. It is filling water at 30 liters per minute. The capacity of tank is 500 liters. And there is a leak B which is emptying at the rate. The water is flowing out from this leakage and it is emptying at the rate, let's say 20 liters per minute. Now let's try and understand this question. Okay. Now in how much time this tank can be filled if both A and B are open? Now what will happen? Now for filling, this is a positive work because this is trying to fill, right? And this is trying to empty. So this is the negative work. This is the concept of negative work. In every 1 minute, what will happen? The filler will send 30 liter water in and the leakage will take out 20 liter water. The filler will fill 30 liter water in and the leakage will take out 20 liter water from this, right? So effectively, what will be the net input in 1 minute? It will be 30 minus 20, that is 10 liter per minute. So here we can say speed of A is plus 30 liter per minute and speed of B is minus 20 liter per minute. That means combined speed of A and B will be 30 minus 20, that is plus 10 liter per minute. That means the tank can be filled. Always remember, if the filling speed is higher, emptying speed is lower, tank can be filled. So the time taken to fill the tank when both A and B are open, or we can say the time together for AB, will be equal to the capacity of tank, so total capacity, that is total work, divided by the net speed. Right? That method does not change. The calculation of time does not change. So it is total capacity is 500 liters and net speed is this one, combined speed of AB, that is 10 liter per minute. So which is equal to 50 minutes. So the tank will be filled in 50 minutes. Alright, so this is the basic logic of negative work. Let's take some questions on this. Now let's take a look at this question. It says tap A alone can fill a tank in 40 minutes. And a leakage B can empty a full tank alone in 90 minutes, right? In how much time the tank will be filled if both A and B are open, right? Here the times are given. Time to do the whole work is given. Now, do you remember the method 2, the formula method? Method 2, the formula method for the positive workers. Okay. There we had the formula for 2 people timed together for 2 workers or 2 people was equal to T1 into T2 upon T2 plus T1, right? Here also the same formula can be applied. It is just that there is one positive worker and one negative worker, right? Let's say this time is T1 and this time is T2. In the formula what we will do, we will just put a minus sign in place of plus sign. Right, so it is T1 into T2 upon T2 minus T1. Remember this. Look at the order of this. Right. So if T1 is the time to fill or time to do positive work and T2 is time to empty. If these are the individual times given, or you can say the time to do the negative work, alright. The time together is straight away T1 into T2 upon T2 minus T1. So the way we had for positive workers, it was T1 into T2 upon T2 plus T1. For negative work, it will be T1 into T2 upon T2 minus T1. One person should be doing positive work, one person should be doing negative work. T1 and T2 are their individual times. T1, T2 are the individual times for the whole work. Individual times for the whole work. Right? So this formula can be directly applied. Okay. So in this case, T1 is given as 40 minutes. T2 is given as 90 minutes. Now one more important thing. Why T2 minus T1? Why not T1 minus T2? Here we are assuming that T1 is the time for positive worker, T2 is the time for negative worker. Then the value of T1 has to be less than the value of T2. Why? T1 and T2 are the time for the same work, right? So the one that has less time will have more speed. If we want the work to be done, if we want the tank to be filled, that means the time taken for the positive work should be less, so that the speed of the positive work is high. Similarly, the time taken to do the negative work, that means emptying, should be more, so that the speed of emptying is less. See, the tank can be filled only if the speed of filling is higher than speed of emptying. Alright, so in this case, T2 has to be greater than T1. Now, if T2 is greater than T1, then we must take T2 minus T1. Because if we take T1 minus T2, we'll get the negative value for time, which is not possible. Right? So T2 has to be more than T1. T2 is the negative worker, T1 is the positive worker. Alright? So in this case, the time together will be straight away equal to 40 into 90 divided by 90 minus 40. So it is 3600 divided by 50, 360 by 5, which is 72 minutes. So this was one very beautiful question and directly based on the formula T1 into T2 upon T2 minus T1, because there is one positive worker and there is one negative worker. Alright, now let's take another method for the same question. As we said earlier, this formula can be used only in those situations where both the workers are working from beginning to the end. Alright, in all other cases we'll use the other method, let's say method 3, that was LCM method. Right? LCM method. So we'll take the total work. Here the total work is the capacity of tank. So total work is equal to LCM of times. Now whatever times are given, so 40 and 90. Now what is LCM of 40 and 90? It is, you can see, 360. So 360 liter is the capacity of tank. You can calculate the LCM 40, 90. So if you take 10 common, you will get 4 and 9 here. And 10 into 4 is 40 into 90, that is 40 into 9, that is 360 liter. So what will happen, we will get the speed of A as total work 360 liter. A takes 40 minutes to do it. So 360 liters by 40 minutes, that means it gives us 9 liters per minute. And speed of B takes 90 minutes to empty the full tank. That means 360 liters divided by 90 minutes. And its speed will be 360 by 90 is 4 liters per minute. The only thing you have to be careful here is the speed of A is positive, speed of B is negative. That means the combined speed of A and B, when you add 9 and minus 4, it will become plus 5 liters per minute. Alright. So this becomes very simple to understand. So the time taken by AB together will be total work 360 liter divided by the net speed, that is 5 liter per minute. Now 360 by 5 is equal to 72 minutes. So this was one very beautiful method to do this question. Alright, let's take one more question like this. Alright, now this question says tap A alone can fill a tank in 45 minutes, but due to a leakage it takes 60 minutes to fill the tank. Alright, in how much time the leak alone can empty the full tank? That means if I say the tap A, time taken by A for the full tank, that is 45 minutes. Time taken by B for the full tank, this is what we have to calculate. And the time taken together is given 60 minutes. Please understand the question. It says it takes 60 minutes due to a leakage. That means both tap A and the leakage are working together and it takes 60 minutes. So time together is 60 minutes. So this is time together. And we also have the formula for time together. It is T1 into T2 divided by, now this is the negative work situation. Leakage is negative worker. So it is T2 minus T1. Here T1 is 45 minutes, T2 is the time taken by the leakage. This is what we have to calculate. And time together is 60. So we have 60 equal to, so we can directly apply this method. This is, let's say, method 1. Right? So straight away we can start from here only, that 60 is equal to T1 is 45 into T2 divided by T2 minus 45. Be very careful about the order, because if you don't follow that, answer will be wrong. Right? Now 15 cancels 64 times, 15 cancels 45 3 times. If you cross multiply, T2 minus 45 comes here. So it is 4T2 minus 4 into 45 equal to 3T2. Now 4 into 45 goes to the right hand side, 3 into T2 comes to the left hand side. So 4T2 minus 3T2 is equal to 4 into 45, which is equal to 180. So 4T2 minus 3T2 is T2, right? So we have T2 equal to 180 minutes. Now what is T2? It was the time taken by the leakage, B leakage. We assumed B to be leakage. That is equal to 180 minutes to empty the full tank. Right? So this was one beautiful method of doing this question. Let's take another method of doing this, LCM method. How do we apply the LCM method in this? Here, the time taken by the filler, again I'll write it here, time taken by A is given 45 minutes. Time taken by B is not known, this is what we have to calculate, and time taken by AB together is given 60 minutes. So let's take LCM of 60 and 45 for the total work. So in this case, the total work will be LCM of 45 and 60, which is equal to 45 and 60 LCM will be 180 liters. Alright. That means the speed of A will be 180 liters divided by the time taken by A is 45 minutes. So it is equal to 180 by 45, 4 liters per minute. And remember, it is plus 4 liters per minute. Speed of B we do not know. What about speed of A and B together? Look at this very carefully. Time of A and B is 60 minutes. So speed of A and B together will be 180 liters divided by 60 minutes, which is equal to 3 liters per minute. And tank is being filled. So this is also plus 3. Now this is a tricky situation. Speed of A is 4 liters per minute. Combined speed of A and B is 3 liters per minute. So what must be the speed of B? Guess it from your side. Speed of A is 4 liters per minute. Speed of AB, that is combined speed of AB, is 3 liters per minute. That means speed of B must be 3 minus 4, which is minus 1 liter per minute. So minus sign only shows that it is a leakage. So it is confirmed that this is a leakage, and the speed is, value is 1 liter per minute. So what will be the time taken? What will be the time taken for B? You can calculate the speed of B is the magnitude, the value is 1 liter per minute. Remember, minus sign only shows that it is a leakage. So the time taken by B for emptying the whole tank will be 180 liters divided by 1 liter per minute. So 180 by 1 is 180 minutes. Right? So time taken by the leakage to empty the full tank is 180 minutes. Right? So this was one very beautiful situation. In this particular question, there is another method, and this is method 3. It is a logical method. Let's see if you can understand. Right? It's not that difficult. Let's see. What is the question saying? Again, every method is independent, so don't mix them. Okay. Tap A alone can fill a tank in 45 minutes. So can I say that the tank is equivalent or equal to 45 minutes of filler? 45 minutes of filler, and it is equal to X minutes, equivalent to X minutes of leakage. Just try and understand this, trying to explain the question here. The tank full capacity can be filled by the filler alone in 45 minutes. So we can say the tank is equal to 45 minutes of filler. Now, we have assumed that the leakage takes X minute to empty the full tank. So tank is also equal to X minutes of leakage. Alright. Now read the question carefully. Tap A alone can fill a tank in 45 minutes. But due to a leakage, it takes 60 minutes. See, out of this 60 minutes, it was supposed to take 45 minutes anyways. So is there any extra work that it has done? Yes. What is the extra work done by? Extra work done by the filler. What is it? Extra work done by the filler is 15 minutes of filler. I am writing the work done in terms of time. So extra work done by the filler is 15 minutes of filler. Why is it doing the extra work? If you understand that, if you can answer that, it will be very easy for you. See, again, out of 60 minutes, the filler was anyway supposed to take 45 minutes. That means the filler has taken only 15 minutes extra. Why did it take extra? Because there was a leakage. For how long has the leakage worked? Now the leakage has worked from beginning to the end, which it was not supposed to. So the entire work done by leakage is 60 minutes. 60 minutes of leakage. Now comes the biggest thing. What is the relation between these two? Whatever extra work is done by the filler, which is 15 minutes of filler, why did it do the extra work in first place? It did the extra work because leakage took out some water from it. Right? And how much water was taken out by leakage? It was 60 minutes. So the extra work done by filler is equal to total work done by leakage. Total work by leakage. Try and understand this. You can directly memorize that extra work done by filler and the total work done by leakage, they must be equal. Okay, so I'll straight away write 15 minutes of filler are equal to 60 minutes of leakage. Right? But we need to find the equivalence to tank for the leakage. Now equivalence to tank is 45 minutes of filler. So if we have 15 minutes of filler equal to 60 minutes of leakage, that means 45 minutes of filler, you can directly calculate from here, it will be equal to, now 15 how many times is 45? 3 times. So 63 times will be 180 minutes of leakage. Right? But yeah, the most important part, so the answer is 180 minutes. The full tank, this 45 minutes of filler is equal to tank. So 180 minutes of leakage will also be tank. So full tank can be emptied by the leakage in 180 minutes. But the most important part was this one, right? That you have to understand that extra work done by the filler is equal to total work done by the leakage, right? Because 45 minutes it was anyway supposed to take. It has taken to total 60 minutes. So out of 60, 45 remove, you get 15 minutes of filler. So extra work done by filler is 15 minutes. Total work done by leakage is in 60 minutes. So total work done by leakage in 60 minutes is equal to extra work done by filler in 15 minutes. So we can directly say 15 minutes of filler are equivalent to 60 minutes of leakage. Or 1 minute of filler is equal to 4 minutes of leakage. From there, 45 minutes of filler will be equal to 4 into 45, that is 180 minutes of leakage. So the answer of that question will be 180 minutes. So time taken by leakage to empty the full tank will be 180 minutes. So this was a good concept for negative work. Okay, let's take one last question for the negative work. Now let's take a look at this question. It says taps A and B can fill a tank in 15 minutes and 20 minutes respectively. That means A alone can fill the tank in 15 minutes, B alone can fill the tank in 20 minutes. A leak alone can empty the same tank in 30 minutes. In how much time will the tank be full if all the three are open, right? So this is the tank. There are two fillers. One of them takes 15 minutes. One of them takes 20 minutes to fill the tank alone. And there is a leakage which takes 30 minutes to empty the full tank. Now see, very simply, here because there are more than two workers, we'll simply use LCM method. And in LCM method, what do? We take total work is equal to LCM of their times. The times are 15, 20 and 30. So LCM of 15, 20 and 30, you can calculate it is 60. And tank is there, so we can take 60 liters as the total work or the capacity of tank. From there we get speed of A. Let's give them some name. This is A, this is B, and let's say this is C. So speed of A will be 60 liters divided by, what does A do? It does the entire 60 liter tank, A fills the entire 60 liter tank in 15 minutes. So speed of A will be 60 liter divided by 15 minutes. Now 60 by 15 is 4, so it is 4 liter per minute. And speed of B will be 60 liters. Now B takes 20 minutes to fill 60 liters. So it is divided by 20 minutes. So it is 3 liters per minute. And speed of C will be same capacity 60 liter divided by, the time is 30 minutes. Alright. So 30 minutes it will be equal to 60 by 30, that is 2 liters per minute. But not to forget, the speed of C will be negative, speed of A and B will be positive. So what will be the combined speed of A, B, C together? Look at that carefully. If you add all of them, plus 4 plus 3 minus 2. 4 plus 3 is 7. 7 minus 2 is plus 5 liter per minute. That means the tank will be filled. See, if the net speed comes out to be positive, the tank can be filled. Right? So the time taken by ABC together will be total work, that is the capacity of tank, divided by the net speed. Right? Net speed is the combined speed. Total work here is 60 liters. Net speed is 5 liter per minute. 5 liter per minute. So we get 5 cancels 60 12 times. So 12 minutes is the answer of this question. Alright, so we have completed all the methods, basic methods related to the speed, work and general formula method. We have also used LCM method. Alright, now let's go for the next topics and some good questions.